Okay, so in this segment, we'll talk to Sean here about building OneGraph.com. And I'm sure a lot of you already know Sean, but for those who don't, would you mind starting out by introducing yourself and kind of what led you to ReasonML and who you are?
Yeah, yeah, sure. So I work at a company called OneGraph. Before that, I ran engineering for a payments company, and that company was in Clojure, and I really like Clojure. Before that, I'd been spending a lot of time working on developer tooling, so at companies like Sauce Labs a long, long time ago. So like good developer tooling is near and dear to my heart. But I really wanted to have a more thorough kind of type system is like a means to an end for me. So Clojure has lots of really nice tools, but what I found is that oftentimes I would make a mistake, maybe in the REPL, and I hadn't updated the source code or something along those lines, and I felt like it was obvious when you looked at it, and I couldn't understand why the computer wasn't helping me more, right? Like if I could see it, this is obviously something the computer should be able to help me with. I can't remember everything across this huge code base. So that's led me to converting over some of the stuff to OCaml at the time. Built, I think we were the first company to ever deploy the Mirage unikernel in production, which has both pros and cons, but it's a very cool project. That was like on a very small project where we could test it out to make sure it was all right. But then, Reason came along, and the buckle strip compiler came along, and it's definitely kind of changed the way working in OCaml feels, or Reason feels. And so it feels like it's definitely possible to build the systems I was frustrated with beforehand inside of Reason now, right? Like it's actually a much nicer experience overall once you get over some hurdles.
Cool. So OneGraph.com.
Mm-hmm.
What is that?
Yeah, you want to give the pitch?
Yeah, I know it by now, but so like, let's maybe start with what you do, and then we'll continue to how you're using Reason for that.
Sure. So OneGraph, the idea on the surface is very simple. It's basically just one API endpoint that kind of brings together lots of separate public APIs. So you can imagine that your business probably uses Salesforce and Stripe and maybe Zendesk, right? So this is like a kind of common combination that you might have. But to interact with these systems programmatically is radically different, right? Each one, like Salesforce has its own custom SQL dialect that they use. Stripe has, beautiful API, but very resty. Zendesk's is a little bit more one-off. And then on top of that, there's this challenge where you have data that is actually related to each other, right? Across these different systems. It's effectively sharded in some ways. And it's sharded in a way where you don't really want it to be. You don't want to think of it like this. You have like a customer, and a customer has maybe some leads or opportunities inside of Salesforce. They have some payments inside of Stripe, and they have some support issues over inside of Zendesk. And you want to think about that kind of coherently as like one unified graph. And so OneGraph is effectively an attempt to kind of map out that graph so that you have one way to access all of these different APIs in a kind of like unified manner. So it's learn once and then hit any API. And then also to provide relationships between these different systems, right? So that you can kind of query into Salesforce and say, having gotten this opportunity, do we have any support tickets open inside of Zendesk for them before I call them? Or, let me go ahead and reach into Stripe and pull out any refunds that have pulled up recently for this customer so I can see if they're upset about anything. Yeah, so that's the high level idea. There's lots of other stuff that falls out of it, but that's the kind of the simple pitch.
Yeah. Awesome.
Oh, and then for Reason, part of the reason why it's so important is because Reason is like this beautiful type system for everything that the compiler can see, right? So just like I was talking about beforehand, the frustration that I had with Clojure, where it would just miss some very obvious things. Reason doesn't have that. except for whenever you're talking to anything outside of
right.
Reason. So if you're trying to parse some JSON, like the compiler can't help you at all, right? And so it becomes this really big faff to interact with outside systems. And these days, this is the thing we hit with the Mirage unikernel immediately was everything is done via APIs, right? Logging is done via APIs and payments are done via APIs and all of them talk JSON. And so if we got some type annotation wrong where it changed upstream, we would crash in production.
Yeah.
And it was so difficult to kind of keep that in sync. So with GraphQL, you have a relatively modest type system, but one that can be introspected. And so there's all this great tooling for Reason that will just say, hey, give me the OneGraph schema or any GraphQL schema, and I will tell you at compile time if your query is correct. And not only if it's correct, but like if you're using all of the fields in a type-safe way, if you checked for nullability, et cetera, et cetera. So you can always be sure, like with no extra work on your part, you can be sure that Reason is now type checking all of the outside world for you as well, right? So that you know that you're not going to have any of these crashes at runtime.
Yeah, that's a very interesting aspect of it.
Just a question. So you can basically, people provide the schemas for you and you can fetch them at compile time or some unit test time and check them before you're actually deploying your product to that version. Is that correct?
Exactly. So there are two things that go into this. So one, GraphQL itself has a culture of not making breaking changes, right? So once you have ever released a schema out to the world, you don't know who relies on that, right? So like anyone might have relied on it, and they might have like relied on it in a way where they've written some code that references a field that they just haven't hit yet. And so, maybe that client gets loaded up 6 months later, and now they hit it. And if you have removed that field or broken that field in some way, you're going to break that client. So in GraphQL, the culture is just deprecate, don't show it to the new clients, tell people not to use it, but you still support it, right? Maybe under the hood, you map it the other way. So that way you still maintain those guarantees that the compiler were giving to that person when they compile that code. Then the next one is on top of that, at development time for a Reason person, if you're using something like Reason Relay or Reason Apollo or Reason Urkel, it will just go out, fetch the GraphQL schema, and then store it as a local JSON file. And from then on, all the tooling knows how to work. So it's basically like a little PPX that runs beforehand, and it just checks all of your code to make sure that it matches with the schema that it downloaded. And so even if the schema has changed upstream, it doesn't really matter because you're just not taking advantage of any of the new stuff. And because of the cultural things, you shouldn't have have anything that's been broken in the meantime. So as long as it compiles locally, you should be pretty confident that this is going to work for the long term.
Interesting.
Cool.
So moving deeper into Reason then, how are you using Reason at OneGraph? Is it backend, both back and front end? Is it part Reason, all Reason?
No, we have a smattering of technologies these days. We have JavaScript on the front end. We originally had some Reason on the front end, but we removed it probably in 2017, maybe very early 2018. But I think probably it was already gone by 2018. And I'll get to why later. On the back end, it's all Reason native, except for a pre-generation phase. We have some tooling written in Clojure that actually will ingest some upstream stuff, does some data manipulation, and actually then generates hundreds of thousands of lines of Reason for us. More recently, we've started to move away from that. We need to have some more dynamic generation of these schemas. So we're starting to bring more and more of that into Reason. One other thing is we have a couple of external services that are written in Node. I think exclusively Node. You can kind of think of them as doing some there's so much effort that's already been expended. So one of them is NPM's package management system. They actually have a Couchbase instance that you can subscribe to, and they will send you notifications anytime a new package is published. So we will actually take those and convert them into GraphQL subscriptions. So on OneGraph, you can just go and subscribe to any new packages being published. But if you imagine what that would mean if we were to implement that in Reason Native, right, we'd have to implement a Couchbase client from scratch and then connect to it and then figure all that out. So our quick solution was stand up a tiny little shim service with, npm, install that Couchbase npm package, connect to the thing, and then just stream it to OneGraph by HTTP. That said, earlier this morning, we literally just implemented the Couchbase client stuff for Reason Native, so we'll probably be getting rid of that one too.
And because that has been kind of a recurring theme for you, right? That you've had to reinvent quite a few things for Reason in order to run what you need to run and at the scale you're at.
Yeah, exactly. I think the way I think about it is, you have this aspiration to get to a pure Reason world where everything's kind of type safe and you can take advantage of all of the refactoring abilities that they give you, et cetera, et cetera. But you also have to be kind of realistic about it and figure out what's the path to get there, right? If we did that exclusively in Reason Native right now, we either wouldn't have shipped or we'd have something like 1/10 of the coverage that we have right now.
Yeah.
And so what we did is, I spent probably the first 6 months, 8 months, year, just writing very low level stuff like HTTP, multi-part form encoding, parsers, and that kind of thing. Because it didn't really exist. But then for other stuff, once we expose this to users and they want features on, the order of days, maybe weeks, not months or years, we had to figure out what's the quickest way we can stand up some other service or some other piece and get this to work before we kind of bring that in and amalgamate it into a native Reason world.
I have a question regarding the node integration. It sounds to me like you basically started with this before BuckleScript was even a thing. So you stuck to native mostly. I started off with OCaml, and you basically converted to using Reason syntax. Is that correct?
Yep.
And you're not using
BuckleScript was a thing at the time,
okay.
but it was very early. It was still a Bloomberg project.
Okay, but you're not using any BuckleScript on the backend then? If you're integrating with Node, you're sticking to plain Node and then integrating with the native Reason. With
exactly. Yeah, so we have no Node in deployment on our OneGraph servers. And the reason was I wanted to just I love having a pure binary that like I can just spin up a super dumb system, put it on there, and it just runs. Right, like there's no worrying about environmental variables or like node versions or FNM versus whatever the other one is called, like and on and on. Like it's just here's a binary, run it. Yeah. Right, it's a statically linked binary that has everything it needs, and you're just done.
Okay.
But to that point, like BuckleScript was a thing, and we actually the aspiration, and this is still in my heart of hearts, an aspiration for our front end to have be written in Reason. But at the time, our dashboard is also consuming OneGraph via GraphQL, and wrapping the Apollo client at the time was very, very challenging. Wrapping any Reason, React component was very challenging because it was still kind of the class-based world. And so you had like these two functions. One was like wrap this Reason React component for JavaScript, and wrap this JavaScript component for Reason React. And you had to like put in the objects, like the types there. And if you got that wrong, it would also crash at runtime. And so writing bindings was a lot of work. And it would crash all the time. And so we switched over to Flow so that we could the idea was like, well, we're not moving quickly with this and we're not getting type safety. So like, this is not worth it. These days, however, the encoding for BuckleScript is so much better. And the reason like functional stuff is so much better. So that, we do one-off stuff for different clients every now and then. And I'll often write that in Reason React. And it's so much better. And it's so much better than the experience I have in Flow these days. So I still hope to be able to start to port over bit by bit our front end to Reason when the time comes, because it's either we're going to get off of Flow and it will either be TypeScript or Reason, and I'd like it to be Reason. That said, we are missing one of the biggest, or binding is one of the biggest packages, which is GraphQL JS. right? So being able to parse GraphQL queries, operate on the ASTs, do transformations, that kind of thing. Like those two type systems are difficult to merge together, Reasons type systems and GraphQL type systems. And I don't want to be the one who writes that because I'm going to get it wrong. And then we're going to have crashes anyway. And then we're going to be sad that we have Reason in production. So if we could get that package, I think I can write, I'm happy to write bindings for everything else.
Okay. Yeah. So people listening here, you got a job to do.
Yeah. I'd also be interested in using that, not writing it, but using it.
Yes.
But so me, it seems like now that the hooks is like the de facto way of doing things with Reason React is much easier to integrate with.
Oh, it's night and day difference. It is so much better.
Nice. We actually have a question from chat from Sridhar Reddy. I hope I don't butcher your name. He basically said, so now if you had started, would you use Reason? Like if you started fresh right now?
I think so, yes. And put this in perspective, my co-founder was on the Relay team at Facebook. And so he also has a way more patience than I do. So he was the one who basically took over the front end and brought in Flow because he was already fast with Flow and everything. And he ripped out my Reason code. And I couldn't argue with his results. Like he was just moving much faster. I think these days I could argue because I could actually move faster, right? Because everything is hooks based, because the bindings are so lightweight, et cetera, et cetera. Yeah, it would be much. And then on top of that, you have things like Reason Relay, which we would definitely be using today if we rewrote it all. So like that would definitely be my ideal front end right now, is to use Reason with Reason Relay against OneGraph. That would be a dream setup.
But you're using Relay now for the dashboard, or?
We're using Apollo. We will probably move over to Relay as part of the next transition.
Right.
Like I said, my co-founder was on the Relay team. So every time he suggested that we move to Relay, I was like, no, you're not really, you're a biased source. Like Apollo is fine. And then I finally looked into it, and yeah, Relay is just amazing. And I feel silly for having used Apollo for so long.
So I think we can transition into our next question here. You touched on it already, but so like roughly how does the architecture look? So you mentioned you have a bunch of small services also, like the node service and that, but for the Reason native stuff, is that also like more of a microservice architecture, or do you have a monolith? Or
I would even argue that we don't really have a microservice architecture. I mean, maybe kind of, but it's almost entirely monolithic. So we effectively have some data descriptions of different APIs and then some transformation layers on top of them, because oftentimes the data descriptions that we get from partners are not complete or not entirely accurate. It's very difficult if you're not using GraphQL to model your API, to make sure that your type definitions and your documentation stays in sync with the actual implementation. And so what we do is we want to take those data definitions that they give us, but then we apply a bunch of transformations that we have discovered from production on top of that. So then we have a pipeline during build, which will read all of that and then generate some Reason code. That Reason code then gets compiled into our bigger project. And then it runs through Circle CI for all that. And we get something like, I think 600,000 lines of code. With our recent refactorings, we've literally cut off something like 300,000 lines of code. It's been like the ability to refactor things in Reason is just tremendous. It's amazing. We've just been hacking and slashing, and things have been rock stable. And then once it's in production, so basically every time we push, Circle CI will run everything. It does the new reanalyze dead code elimination check. It does the uncaught exceptions check. We run a bunch of sanity checks, and then we spin up a bunch of new servers. So just kind of CI/CD. And then in production, we have just a few services outside of OneGraph. So one of them is the NPM Couchbase thing. And like I said, we're moving that into OneGraph monolith because we are not a microservices shop. It's very challenging for people at our scale, I think, to run microservices effectively. We do have, like, any microservices are kind of like well isolated and outside, and they have no awareness of OneGraph. Like OneGraph just kind of uses them. There's no like two-way syncing between them. Yeah, so it's basically like we have all this data definition, reason gets generated, pushed to servers, and then maybe it talks to like one or two other services.
Cool. So I think we can actually, I think you've answered most of my other questions, except for we have two very important questions here. And the first one is, let's start with the fun stuff. What has been the biggest upside for you? You mentioned refactoring was one thing, but the biggest upside of using Reason for you, because you've used it for quite a while now and you've shipped a lot of product and a lot of code, kind of. So
yeah, I would say, so there were times where it was unclear if Reason was, because there was a huge cost. Both my co-founder and I were very productive in Clojure and ClojureScript, and the tooling is very good there. And switching over to OCaml, especially like OCaml native and Reason native, was like just hitting a brick wall, right, in terms of productivity, because we didn't know the type system, we didn't know how to like use any C libraries, et cetera, et cetera, et cetera. These days, I feel more and more vindicated because we'll have a customer who comes and asks us for a new feature or I don't know, some change or something. And I haven't touched that code base or that part of the code base because it's a fairly large code base in, I don't know, 8 months. And I'll go in and I can just hack fearlessly, right? Like I just literally start adding things and testing, and like Merlin and my editor will just tell me as soon as I hit save if I've screwed up anything fundamental. And so all of my, the cost of like my loading the context is literally like the business context, right? The feature set. I don't have to worry about like the low level, you know, how does this look like in the database? Is this going to be, you know, did I change the type definition here? And then this is going to cause a runtime exception over there. And some customer is going to lose their data. Like the way I pitch it is that Reason was initially, and again, the starting story today is much different. But at the time, Reason was initially very slow to get started with. But every time we solved a problem with Reason, we didn't really have to revisit that problem, right? Like it just kind of like, it became, you built this base that was stronger and stronger and stronger that you could build higher and higher on, versus maybe something like my experience with, you know, my code in Clojure, where I could build very high very quickly, but I would very often kind of fall over and have to revisit. And in the process of revisiting these lower things that I had built, I would break it even more. Yeah. And so there was never a point where I didn't worry about the whole stack in Clojure or JavaScript for that matter. Whereas in Reason, I just kind of like jump right in and I'm thinking in the context of the product and the feature rather than the entire stack.
So you can actually verify that the thing you can keep reading about with Reason is that like it really enables large refactors without runtime issues afterwards. And this, you're actually living that.
Yes, I think our use case is also a little bit special because at the end of the day, we're generating a GraphQL server. And so we also have this extra verification layer, right? Where our CI, every time we run it, we generate an introspection query and we can compare that with the old one. And so we can compare the schema in production with the schema we're about to generate. And we know if there's going to be any breaking changes, if we have produced bad, a breaking change of some way. And so that means we can do a lot with relatively minor work in terms of, you know, testing and whatnot. So like Reason and GraphQL really kind of come together for us, I think, in that way.
That's a really interesting aspect, that you actually have the double kind of verification there, that you can actually look through like what's actually being generated. And so yeah, that's really cool.
We have a question from chat, if you don't mind.
Sure.
It's about I/O. Like, how do you handle errors? Do you use something like a function like either, or do you just catch and handle an exception at the top?
So this was a really, really big problem for us because when we first started with OCaml or Reason, we did not know, well, at the time, the result. So either I think is Haskellism, but the result is the equivalent in OCaml or Reason,
Yes,
where you
yes.
say it's either okay of this or error of this. And that was not part of the standard library at the time.
Oh,
And
right.
so, and also Reason people, like Reason native people, have an almost perverse focus on performance. And so they made raising exceptions really, really cheap. And so everything raised exceptions, right? Rather than allocate a new boxed result object, just raise an exception and it'd be much faster. So there were two problems. One is we didn't use results because it didn't exist. We just threw exceptions in lots of places. And so did the standard library and all of the libraries we were using. And so we would constantly have crashes in production because an exception had been raised and hadn't been caught in some way. Like we didn't realize that there was going to be an exception here. Luckily, most of the standard library has moved over to a safer alternative where the old functions still exist, but now there's an optional version where you can say, you know, parse an integer, but if it's not a valid string or like a valid integer in the string, then don't throw an exception, just return none. And a lot of the libraries have started using results and whatnot because that's now part of the standard library. The other big thing here is, so we also use Jane Street's core and async, and async has a top level monitor, which will now catch those exceptions. So we haven't had a crash in production for, I don't know, as long as I can remember. It's been a very long time.
Cool.
But we do have lots of exceptions, right? We catch those exceptions, but at least our process still survives. But more recently, we have started identifying all of the cases where we throw exceptions. And actually, Cristiano has released a tool called Reanalyze that we've just integrated, where it will actually check every function and see, does this raise any exceptions? And if so, does it catch them? And if it doesn't catch them, like the difference between those two is those are the exceptions that could escape, right? And cause exceptions elsewhere. And unless you have annotated, add a little like @ symbol at the top of the function saying it's okay for it to raise these specific exceptions, then it will report this as a warning. Okay. And so now we have something like 1,000 functions that raise these exceptions. And we're just going to go through, like we just got this integrated a couple of days ago. And now we actually have a to-do list of like, here are all of the cases where there are exceptions that really should be results. And so we'll just go through, and now we have this as part of our CI. And once we have gotten the 1,000 functions down to 0, then we will turn that on as a build breaking step, right? If you have introduced an exception that hasn't been caught, then fail the build. And so that kind of tooling is so difficult to build outside of something like Reason. So I'm really grateful for Cristiano for doing that, because that's really going to help us to make sure that not only are we not breaking the schema for users, but also we're never going to be giving them like an error that we are unaware of.
Cool. So it sounds to me like you started off using like the standard library and then moved on to using Jane Street's core a bit. And I know core, they're pushing like using result types really hard, right? And labeled arguments in contrary to the standard library, which is basically just exceptions.
Yeah, I think, so even the standard library has started to move over to, so for example, there's like int of string, which is, you know, %, but now there's int of string opt, which says exactly. Don't throw an exception.
Because I know when I started with OCaml or Reason, I was like, coming from JavaScript, I thought that like the standard library is pretty small, but I believe there's like, probably someone in chat can correct me on this, but there's like the standard library is made to actually be able to implement the compiler and the language itself. So it's kept small. Then there's a bunch of like other standard libraries out there, like Jane Street's core, and there's, I don't know, Darklang has one called Tablecloth, right? And we have in the Bucketsweep world, we have Belt, and yeah.
Yep, that's the great thing about standards, right? So many to choose from.
Yeah. Exactly. We have a question from the chat as well. You can continue with you can take the question after.
Oh, I was gonna say that one thing I would really like to see inside of, I mean, there are like a number of like critical things on the Reason like community roadmap in my mind, like things I would really like to see in the compiler, things I'd like to see in the runtime, things I'd like to see in the ecosystem. I think it's really critical in a tight language like Reason to have a relatively rich subset of types that are shared across the entire community. So results, for example, before results was moved into the standard lib, and it's a tiny module, tiny module, and it took forever. But before that, everyone defined their own result type. And so that meant that like, if I wrote a library, I either had to define my own result type, or I had to figure out like, maybe write a functor. So you could use Jane Street's result type, or this result type, or that result type. And what you get is like, it's very much, it creates these islands of development that go off in different directions. And the biggest one we see right now in the native world, I mean, there are like dozens of them. Like OCaml has 2 of everything, but the big one is async runtimes. So there's LWT, which is like the kind of standard-ish one, and then Jane Street's async. And what happens now is if I write something like the OCaml GraphQL server, I want you to be able to use it asynchronously, right? Obviously, we can't block on every kind of IO call or something like that. But I don't know if you're using LWT or async, and I want it to work for both. So I then have to write functors that will, like, basically I define all of the IOs like func calls that I need. And then I say, all right, well, you give me your async implementation and I'll use that. But then on top of that, I have to write my bind and my defer and on and on and on and on. And like all of the nice things means I have to basically reinvent every other library's thing inside of my own code.
Yeah.
And so if we could find a way of moving some of these types that the community has said, these are very valuable, right? IO and async is fundamental to programming today. So maybe we need to have some sort of low-level definition for this so that at the very least, we can share like pool effort around that rather than Jane Street going off in their world, Darkling going off in their world, and OneGraph going off in their world.
Yeah.
But isn't it all almost like, I think I've heard about this, like about like competition, like in the end, there's always going to be like 2 choices. You have like Coca-Cola and Pepsi, you have like Mac and Windows, and you have like that's just how the world works, I guess.
Yeah, no, I think that's absolutely fine, right? So for example, one advantage of LWT, LWT I think is relatively slow compared to Jane Street's core, but it's a pure portable implementation. So you can do really cool things with it. You can take it to like unikernels and compile to JavaScript and do all these crazy things. Whereas async is fast and has lots of nice helper libraries, but it also has like C. So it has like some like unsafe behavior potentially, and it can't compile to all these nice targets and whatnot. That's fine, right? Those are like legitimate, valid trade-offs. The bad thing is it now fractures the entire ecosystem, right? Because I want to say like, I'm building a GraphQL server. I don't care, or an HTTP server. I don't care if you're using LWT or async, right? Like it should be able to work with either one of them. The problem is I now have to figure out how to, like, it doubles my work, right? And it doubles the work for every other package. And then any of these packages that want to interop with one each other, it quadruples their work, right? So suddenly like everyone has to write all these individual bindings to everyone and figure out this entire like type pyramid. And whereas if you move some of those type definitions down, then OCaml GraphQL server can say, well, I use these types and this is all I care about, right? And I use this helper library here. And now you can bring your Jane Street or whatever just for the actual implementation layer. And I don't care what you do.
Yeah, that makes sense. We have a question regarding the reanalyze. Can it infer exceptions caught by LWT catch or LWT async exception hook?
It will, yes. So the idea is that it doesn't do transitive analysis. So for example, imagine you have a top level, like you have an HTTP route that you're handling, like a /admin. And it calls some function, which calls some function, which eventually talks to the database. And that function that talks to the database might raise an exception. The top level like route won't get marked as raising an exception. It's only going to mark that bottom one until like that one it doesn't raise anymore, or like it says it's okay for it to raise these 2 exceptions. in which case the function that calls it will now get marked. And so it kind of works its way from the bottom up. And so LWT catch is going to be catching a function that, an exception inside of one of these things. And so it's going to say, well, hey, you didn't catch this thing raises 3 exceptions, and it looks like you only tried to catch these 2. That said, it also doesn't work with higher order exceptions, which one part of LWT catch or asyncs try with is fundamentally relies on. So there are going to be layers where it's not going to catch it, but it's not really relevant because you're going to see it on each of the individual functions that you're using up until that point.
Okay, cool.
Okay, so I think we're gonna wrap this up here. Thank you very much, Sean, for coming here and talking to us about this. This has been really interesting. And thank you for all the questions in the chat as well. So we'll have a short break again here, and then Dave will talk about CSS in Reason. Thank you again, Sean. And Sean, you're on Twitter as well as you're available on the Discord as well, I guess.
Yeah.
So hit Sean up if you have questions for him. Thank you again.
All right.
Thank you.
Cheers.